In this video, I want to talk about the differences between modified or square wave inverter and pure sine wave inverter. This comparison will be about 80 properties, such as price, noise, load heats up, peak voltage, RFI, internal circuit, load suitability, and load dimming. Here I have two inverters, pure sine wave inverter and square wave inverter. The first factor or property that I want to talk about is the price. The price of my square wave inverter is only $20, while the pure sine wave inverter cost me $55. So the pure sine wave inverter is more expensive, although its power rating is even less than the power rating of the square wave inverter. The second factor that I want to talk about is the noise of the electric load that connected to the inverter. Here I have this 15-watt motor. I would like to compare the sound of the motor when it connected to square wave inverter and then when connected to pure sine wave inverter. By the way, I disconnect the cooling fan of the inverter to doing this test for a few seconds. Let's start and see if you can hear the difference between them. I think the noise in pure sine wave inverter is smoother. The next comparison is the load temperature. In this test, first I run in my motor by using pure sine wave inverter. The temperature of the motor at the beginning was 27 degrees Celsius. After running the motor for 5 minutes, the temperature of the motor became 41 degrees. Then I repeat the same test, but this time by using square wave inverter. The temperature of the motor at the beginning was 27 degrees Celsius. After running the motor for 5 minutes, the temperature became 42 degrees. So the AC voltage with square waveform heats up the load slightly more. The next property is the peak voltage of the output AC waveform. First off, let's see the output waveform of the pure sine wave inverter on the oscilloscope. As you can see here, the RMS voltage is 228 volt, while the peak voltage is 320 volt. And for square wave inverter, the output voltage is 233 volt RMS, while the peak voltage is 264 volt. In electric and electronic engineering, there are a term so-called crest factor. Crest factor is the ratio of the peak voltage to RMS voltage. In sine wave, the crest factor is equal to 1.4, but in the square wave, the crest factor is equal to 1. However, in my square wave inverter, the crest factor is slightly more than 1. That's because it is not a perfect square wave. The next property is RFI. RFI stands for radio frequency interference. It is some radiation that causes noise on your radio. First, I run in a 15-watt LED lamp by using pure sine wave inverter. Then I set my radio to LW 333 kHz and I put the radio close to the inverter. In this case, I can't hear any significant noise from the radio. I repeat the test, but this time by using square wave inverter. So as you can see here, the square wave inverter produced a lot of RFI. The reason for that because the square wave has a lot of harmonics. And you can see some of them by using FFT function of your oscilloscope. But the pure sine wave has no harmonics. Only fundamental frequency, which is 50 Hz in this case. In the real life, when you're using square wave inverter, the RFI situation would be even worse. Because the long wire that connects the inverter to the entire house can act in as an antenna. and radiate more RFI and noise to the radio and audio devices. The next comparison is the internal circuit. I tear down both these two inverters to see the circuit inside. As you can see, the pure sine wave inverter is much more complex. The funny thing about this cheap Chinese square wave inverter that it should be has a buzzer, but I can't see any buzzer inside. The pure sine wave inverter usually has big inductor and big capacitor as an LC low-pass filter to convert SPWM to pure sine wave. But the square wave inverter has no filtering circuit. The next property is the load dimmability. Here I have a dimmer and incandescent lamp. The dimming process can be done very well when the inverter is pure sine wave, as you can see here. But by using square wave inverter, there are some problems. As you can see here, the phase angle cannot be adjusted at the negative side of the waveform. And finally, the last thing to be compared is load suitability. In this comparison, I want to see if there are any load that cannot be running by square wave inverter. Here I have this socket AC voltmeter. It is working very well with pure sine wave inverter. But see what happened when I connect it to square wave inverter. As you can see, it go crazy and reading voltage about 480 volts. The next load is an LCD TV. First I run it with pure sine wave inverter. And as you can see, it's working very well. But when I try to run it with square wave inverter, it just working for 1 second, then switched off. I found that the problem is not from the TV itself, but from the power supply of the TV. I use this socket adapter because it has LED lamp indicator. As you can see, when I connect the power supply to the inverter, the output voltage of the inverter become unstable, even when no load connected to the power supply. I think that because of the EMI filter that located inside the power supply, to filter out any noise from the mains voltage, but it seems to be not friendly with the square wave. Luckily, I have another power supply, and it's working well with the square wave inverter. The last thing that I want to say in this video, if you one day find an inverter in the trash and you wonder it is pure sine wave or not, you can connect a diode bridge and high voltage capacitor to the output of the inverter. Then measure the voltage across the capacitor by using DC voltmeter. If the voltage was more than 300 volts, so the inverter is pure sine wave. But if the voltage was something around 250 or 260, so your inverter is just a modified or square wave. Because as I said before, in pure sine, the peak voltage is very high. Actually, these mismatched peak voltages in square wave and pure sine wave sometimes can cause us a problem. For example, if you're using the old linear power supply that has no regulation IC inside, its output voltage will be less than expected when you connect it to the square wave inverter. But with the pure sine wave inverter, there are no problem at all. So if you're using some LED lamp, for example, as a load, the light intensity will be less with square wave inverter, as you can see here. However, if your power supply was switching mode, the output voltage will be the same, whether your inverter is square wave or pure sine wave. By the way, the output voltage of the inverter is very dangerous, so please be careful. I have a video in my channel that show you how to convert your modified or square wave inverter to pure sine wave inverter. I'll leave the link of that video below in the description. Please like this video and subscribe to my channel. Thanks for watching.